Okay, ball is dropped from rest. Alright, so U is 0. From a point above a smooth horizontal floor, the ball falls vertically for 0.8 seconds. So T is 0.8. Before it hits the floor and bounces to a height of 0.9 meters above the floor. Calculate the speed of the ball when it first hits the floor. So if the ball is falling, obviously it's released from rest, okay, it falls to 0.8 seconds. When it hits the floor, it'll have a velocity of v, which we'll work out now, okay, and of course acceleration, okay, well this was falling under gravity, acceleration will be 9.8, yeah, and we can write as positive 9.8 because we can think of downwards as positive, can't we? Okay, so you know, if I draw a little diagram of this, right, so suppose that's where the ball is released at a certain height above the ground. Notice they don't tell me the height, but here's the ground, so the ball is released, okay, and it hits the ground. Okay, so when it's released, the initial velocity is 0, and of course we want to know what the speed is here when it hits the ground. Okay, that takes 0.8 seconds, but we're taking downwards positive. Okay, so of course it's accelerating at a rate of 9.8, taken downwards as positive, with gravity there being positive, then because downwards is positive. So if we use v equals u plus at, v will equal to 0 plus 9.8 times time, which is 0.8. So you can get your velocity out there to be 7.84 meters per second. Okay. It bounces then, it says, to a height of 0.9 meters above the floor. Okay. Find the coefficient of restitution. So we've answered part A, haven't we now? We've found the speed when it hits the ground. Find the coefficient of restitution between the floor and the ball. Give your answer correct to 3 significant figures. Okay, so we've got an impact, haven't we, when it hits the ground. Alright. Now we need to work out what the coefficient of restitution is. Okay. If we look at part B, when it leaves the ground, okay, it hits the ground, isn't it? Speed 7.84. But when it leaves the ground, it's going to bounce upwards, right? But we don't know, when it bounces upwards, we don't know what that speed's going to be when it's bouncing upwards. Because when it hits the ground, it's going to lose some speed, right? So even though it hits at 7.84 meters per second, it's not going to bounce up then at 7.84 meters per second. So it hits the ground at 7.84, it's going to lose speed because it loses energy when it hits that ground. So when it bounces up, it's going to bounce up at a different speed. So I don't know what that is, it doesn't tell me. But what I do know is, it rises to 0.9 meters. Okay, it rises to a height of 0.9 meters till it comes to a stop. So we know the final velocity is 0 when it comes to a stop at 0.9 meters, because that's the furthest it can go. Okay. Now, if we consider this as a new situation, after it bounces going up, okay, now we take upwards as positive, which means then, of course, acceleration will be minus 9.8, yeah? Because acceleration, of course, acts downwards, doesn't it, due to gravity, okay? But we take it upwards as positive this time. U, when it bounces off the ground, we don't know what it is, okay? But we know V is 0, and we know S is 0.9, okay? Because we know the height it gets to. So we can use these now to work out what the initial speed is. So I think we can use v squared equals u squared plus 2as. So v is 0, u we want to find out, minus 9.8 for a, and then s is 0.9. So u squared will equal, basically, these times together. Okay, so 2 times 9.8 times 0.9. So my calculator, I get 17.64. And I'm just going to square root that, and I get 4.2. So it hits the ground at 7.84. right? It hits the ground at 7.4, it loses energy and that impact, and it bounces off at a speed of 4.2. So to get the coefficient of restitution, remember it's the speed of separation divided by the speed of approach. So speed of separation is 4.2, speed of approach is 7.84. So you can get your E just by dividing those two, and we get out a value to be 15 over 28, okay, or 0.5. Does it say any three significant figures? So that would be 0.536 rounded, so three significant figures.